Still, some are remaining or all have come. So yesterday we performed field testing. So we also collected UDS sample in the Shelby tube. So this is the same tube which we collected yesterday. So the total height of this Shelby tube is 600 mm, but we could not collect completely because some space we need to left so that air can be properly removed while we push this Shelby tube into the soil. So we have collected a certain height of the soil, that is around 300 mm. And now, as you know that this undisturbed sample is used for shear strength parameters and consolidation compressibility properties. So first, can anyone guess which sample we should extract first, oidometer or UC or UU test? Oidometer sample is just 20 mm thickness, and for UCUU we need at least 38 by 76 mm sample. So height of sample is 76 mm. So can anyone guess which sample we should extract first so that the disturbance will be minimum? Because our aim is by doing minimum disturbance we need to extract the samples from this Shelby tube. Anyone? Oidometer. Why?
Because it will, the dimension, the thickness is very less. It is 20-25 mm.
Yes. So if yeah, right. So if you see this, this is the tube in which we will get a sample for UC or UU test. So it will get up to this height. So if I disturb this much soil and then I cut it and then I push it upward and then take oidometer sample, then it will be already too much disturbed. So we do not want that. So first we will take oidometer sample and then after we will take UC and UU samples. So for oidometer samples, we have the same ring in which we perform the oidometer test. This ring is having a diameter of 60 mm and height of 20 mm. So we need to make sure that the height and diameter are within plus minus 0.5. So actually the diameter and height is not exactly 60 and 20. So whatever height and diameter is there, we need to measure it and write down, because it will be used for calculation of bulk density and dry density of the specimen which we have collected from the field. So we also need to note down the empty weight of this ring. How much? So it is 19.74. So around 3-4 readings of height we can take 3-4 readings of diameter we can take, and then we can take average of them to determine the volume of the specimen which we are collecting from this. So we need to also take the empty weight of this ring, and then we need to push it. So while collecting this sample, our aim was to preserve the moisture content, and by minimum disturbance we need to bring it to the lab. So it should not be like put in the truck and it should not be very much disturbed. So now we will remove this wax and then we will collect the specimen. So some amount of soil we will scratch out from the top, because some amount of wax may be mixed with that soil, and then we will take the specimen. So now to extract the oidometer specimen, we need some extra height on both the sides, so that we can easily trim it off and we can get exactly 20 mm sample. So for that extra height we attach a collar on the top and another ring at the bottom side. So on both the side at least 1 centimeter projecting section should be there, so that you can trim it off and you can get exact 20 mm height later. Okay. Yeah. So what is the purpose of greasing all these things? Because while you push the sample inside the ring, there should not be any friction from the walls. Otherwise, additional stresses will be applied on the sample, and the stress state will be changed. So this is the hydraulic ejector. We first put the Shelby tube like this, and then we place our oidometer ring with collar. And this additional ring we put so that some extra height we get on both the sides. So code says at least 1 centimeter height you should have on both the sides. So while trimming you do not disturb the actual specimen height. It should be at least 20 mm. So as you can see, this ejector will push the specimen upward and it will go into the specimen ring. So this silicone grease is very important to be applied, otherwise there will be friction. Silicone spray is to be applied, otherwise there will be friction from the walls of the ring. So now we will push the specimen somewhat more so that whole setup, the oidometer and both the collar will get out, and then we will trim the specimen. This specimen will also give you the data of in situ bulk density, in situ dry density, in situ water content, all the things you can take from this specimen only. So while we will trim this, the extra soil attached to this we will take for water content determination, and already we know the weight of the ring. We will get the weight of ring plus specimen. It will give us the bulk density, and then after getting the water content we can calculate the dry density of the soil.
Is it the same formula gamma T is equal to gamma T upon 1 right?
So these parameters are for bulk density and dry density of the site, in situ density and in situ water.
This extra soil and then prepare for the ring.
So as you can see, at least around 1 centimeter is projecting on both the sides so that we can trim it off. So now we will collect this specimen inside some containers for water content determination.
And one more thing is important, that you need to cut this thing from the periphery
Outside, yeah.
outside.
So,
Otherwise you cut the sample.
while trimming it off, we should start from outside. Otherwise, we will disturb the actual height of the specimen. If you cut like this, it will be very smoothly, yeah. Now some additional sample is also at the bottom side. So if you see the direction of this specimen, when we will load it in the oidometer cell, we will load it from this side. So actually this is similar to what stresses, in what direction the stresses are applied in the field. Like the soil which is above, it is above in the ring. So the direction of the load will remain same. We should not do like that it will be reverted. The bottom should not come at the top. So this top surface is the same direction in which the load is applied in the field. So in every test, whether it is UC test, UU test, consolidation test, the vertical stress which we apply, it should be in the same direction in which the stresses are applied in the field. Because we know that soil is very anisotropic material, and if you change the direction of stress, its behavior will be different. So after trimming it carefully, we will again take the weight, and it will give us the bulk density and dry density. So this is the specimen. So now we will use the same specimen for oidometer test. So like that, if you have the soil tubes or Shelby tubes from different depths, you can collect the specimens and do the oidometer test. Now again we will make it plain. We will scratch the top surface, and then we will use these tubes for collecting the 38 mm diameter and 76 mm height samples. So if you see, the tube is having slightly more height, it is 175 mm in height. So we will get some extra height in this sample so that we can trim it off. And why there are holes provided on the top? If you see, it is similar to this, just a smaller version of this. You can also see the chamfered surface at the bottom, same like Shelby tube. So why these holes are provided? Anyone?
Escape of water.
To protrude it out.
To escape air. So while the sample will be pushed inside, the air will be displaced and it should get some space to get out from the tube. Otherwise, it will cause additional stresses and your soil sample would be disturbed sample. So now we are trimming the above surface and making it plain. Also, when you take the specimen, one specimen, after that some soil we should remove because it is disturbed. Somewhat extent it is disturbed because we have taken one sample. So that's why some amount of soil they are taking out. So when we were in the field yesterday, someone was asking that how we will determine the density of the soil for overburden correction. So we performed the SPT test at 0.5 meter depth and then we collected this UDS sample from 1 meter depth. So can we use this bulk density and dry density for overburden correction? If we know that the strata is uniform, we can use. Otherwise, there are some correlations available based on which you can approximately determine the density of the strata to apply the overburden. And some amount of sample we also collected in a polythene bag. So that came from the split spoon sampler. That was the disturbed sample. So we can use that sample for soil classification. And for soil classification, we need to perform wet sieving, dry sieving, hydrometer test, liquid limit, plastic limit. All these things can be done from that disturbed sample. But the amount of that sample should be sufficient, at least 300 or 500 grams. So yesterday, Gandhi sir was telling that 2 tablespoon of soil they collected from the Shelby tube, from the split spoon sampler. So it should not be done. Proper amount of soil should be there. So proper amount of soil should be there. Otherwise, you will not be able to conduct all the tests. So now we will put these tubes such that the cutting edge is at the downward side, and we will also apply the silicone spray in the same way so that friction can be reduced. And the diameter of this Shelby tube is how much? What is the diameter? 100 mm. So we are getting 38 mm diameter, 3 specimens. So these can be easily extracted from this. So this is the way we put these tubes on the Shelby tube, and then we slowly push it so that soil will be inside the tubes. So while doing this, we need to be very careful. Otherwise, the specimen will be slightly tilted. And as we know that a slight tilt gives the anisotropy to the soil behavior. So it should be purely from vertical direction. So you can see we will fill only up to this height, not to the full height, because
38 by 76.
we need only 76 mm height. So the diameter of tube is already 38 mm. So we need not to care about the diameter. Only we will trim the specimen up to 76 mm height. So we will also show how to get the specimen from this tube to the exact size, 38 mm to 76 mm. 38 mm dia and 76 mm height. During the field testing, someone was also saying that the top portion of this sample is disturbed already, because while augering, when we reached up to that level, due to augering operation, the top portion of the soil is disturbed. But we are not taking that sample. That is at this levels. We are taking from another side. So that disturbed portion we have not touched yet. We have taken specimen from undisturbed portion only.
And this extra sample, if you have sample when you want to do the soil classification, you can put that extra sample.
Yes, so whatever sample we are getting in extra while trimming, we can also use this for soil classification and all, in which disturbed sample is needed. So this is the mold of 38 mm diameter and 76 mm height. So we will use. So now we will extrude this sample inside this mold, and then we will trim the extra specimen. So for that we will use this one, hydraulic extractor. So again we will grease all the portions. Also this sampler. Yeah. Someone is asking. Here. Okay. Okay.
Concentrate an important thing, otherwise you'll and how much carefully you will get stuck. That's an important part that
If some agencies require 50 mm dia sample, so in UC and UU test, in UC test generally we use 38 by 76, but for triaxial testing, some agencies require 50 by 100 mm, 50 mm diameter, 100 mm height. So in that case, only one sample will be collected from this tube. So now the extra. So now the extra soil will be trimmed off and the sample will be leveled. If there are any doubts, any questions, you can ask. So again you can see he is trimming from outside first. If you trim it like this, some portion will be chunked out from the soil mass. The sample would be disturbed. So always trim from outside first, then trim the central portion.
Won't there be any disturbance while extracting these three samples at same time simultaneously?
Sorry.
When you're extracting these three samples simultaneously, won't there be any disturbance in the soil sample while extracting them?
Yes, there is some disturbance in the soil sample, but that is there. मतलब cannot do anything for that.
Hey,
We
his question is,
हाँ.
can you do one
sample
at a time, one, so that the disturbance will be less.
One sample of
But,
UC is instead of three at a time.
but you know that for UC test we need to do at least 3 trials. If you take only one sample and then do the UC test, that UC value is of no use, because at least 3 tests you need to
And
run
if you need
so
to
that
do UU,
repeatability
then
is there.
anyway you require 3 samples at different confining pressure. You have to conduct the test, right? So 3 samples are
3
required.
samples are required.
And usually they don't give you at one depth. They will give you one tube only. So in one tube you need to conduct odometer test. You need to conduct UC test 3 times or UU test 3 different confining pressure. Or if it is direct shear and you can collect the sample, because direct shear is done on the cohesionless soil. If you can collect the sample, then again you need to do 3 times, right? 3 different normal stresses. So that's the.
So normally how much variation we'll get if we do the this UU test for undisturbed sample, this sample and the remolded sample?
Remolded? No.
Undisturbed sample I have collected.
If you have clayey soil and you are using remolded sample, it will change drastically. So you should.
Variation.
It depends like which soil and you need to compare. But as you are having more cohesion in the soil, it will change, because cohesive soil will have stress history that you will remove, right? You remold it. So that's why it is going to be lot of different. It's like 50%, 70%, like this will be there.
So the ideal practice that should be.
That is the common practice across the world. That is that has 100 mm of Shelby tube. Take first sample for the odometer test. The ring. In India we don't do odometer test one, but like when I was in US, I see people do odometer test. So the first thing they take it out, extract the odometer sample, and then they will take 3 tubes, the 38 mm diameter, and then then based on the grain size distribution, you can decide you want to do the DS test or UC test or UU test. So based on that, you need to extract those 3 samples.
From all the phases of the sample, although the structure is intact, but the voids are affected very much from all the surfaces.
No. How?
Because there's smearing effect.
No, but they are removing it. See, every time they are taking 1 inch, 2 inch extra, right? Every time they are taking. They are very much, if you don't do it properly, then obviously you are going to stir.
Then the knife, like cutting
But
it
that
and
is the
that
only.
is affecting the pores. So the draining
That is
condition
only
won't
top
be the
side, but
same.
the whole sample, 20 mm sample, that is all intact. And that is going to play a role in giving you the response, CC value, CR value, CB value. So that only what.
Like especially the drained condition would be affected.
No.
We are just trying to.
Only the top surface you are doing. But when you are using. No. That's not going to. If you are not using this properly and you are not having that extra 1 centimeter, 2 centimeter that how he is doing, then definitely you are going to change your void ratio drastically. Otherwise, you're just planing the surface. That's it. It is not going to impact it. But if you don't do it this properly and don't take extra sample, like he is taking extra sample then trimming it, so that inside the sample ring that is intact. That is not like disturbed. So that is an important part.
Here we are taking the 38 mm diameter, the identical sample from the same test. But if we are taking 50 mm diameter sample, then we will have to go one by one below.
No, I don't think you can have
Then the
more than
depth
one
will change
sample.
like that.
No, only one sample you can have. See, this is 100 mm, and if you do the 50 mm, you have to push it in the one. And you don't have sample more than 250 mm or something. And so you will
So
not
only one
get.
sample will be sufficient.
So
One specimen.
not sufficient. That is very rarely any company asks for that you work on 50 mm. If they say, then they will have same depth, they will provide you 3 samples. But most of the time,
The
even in
diameter
CU
of the
traction,
Shelby tube should be more or less.
नहीं then फिर वो डिस्टर्ब हो जाता है और ये ऑलरेडी बड़ा डायमीटर है. If you are having weathered rock and thing, then you will use 75 mm diameter. This is already the
NX
biggest
size.
size.
NX size.
हाँ, for rock में वो तो करते हैं. फिर rock में तो काफी बड़ा sample आता है. But here we test, like even in CU triaxial, like this bullet train project, they were doing it. It's all 38 mm. CU triaxial, CD triaxial they have done beyond the basic testing. So they have chosen that this location, this depth, you will do CU and CD extra testing. And baki regular testing they have done anyway. So for that also they have used
50 mm
30.
diameter sample is rare.
Very rare. Usually people use in research actually. Usually people use in research. Nobody uses in consultancy work. So that is like CUCD they have done, but they have done on 38 mm diameter and 76 mm height.
That is standard.
That is a standard. All over the world it is a standard actually. It's not only in India that we do. We just don't do it odometer test. But the way we are extracting and doing things, that is standard across the world. Anyone else?
One last thing I would like to add. The specimen after trimming, sometimes what happens, we put it like open like this, and after 2 hours we conduct the UC test or UU test. So then what will happen, the moisture content will change and it will decrease, and it will increase the strength of your soil. So actually the strength is less in the ground and you are calculating overestimating the strength. So always shrink wrap the specimen after collection until further use.
And
Okay.
also put it in the
Desiccator.
Also put it in desiccator is inside when you look at the sample. So now we need to divide into four parts. This is going to decide. Four parts.